In this video, we're going to pick up where we left off in class. We were talking about the normal distribution, which is a probability distribution for continuous random variables. Remember, when we want to calculate probabilities of continuous random variables and represent it with the probability distribution, we actually have to find the area under the curve. The specific curve here is our normal distribution, which is given by its mean and its standard deviation. Mean is mu, standard deviation is sigma. What we can do is we could convert any normal distribution into a standard normal distribution where all of the random variables are now, instead of being x's, they are now z-scores. And our random variable is now given in standard deviation units. So for instance, in the example that we left off in our last class meeting with, it says for a normal distribution, find the probability that an observation is, and in part A, we said at least 2.21 standard deviations below the mean. And so what we did was we drew our normal distribution, we plotted that point 2.21 standard deviations below the mean. Well, if the mean is 0 for a standard normal distribution, and I want to go z-scores or standard normal distribution is given in standard deviation units, all I have to do is go left from 0, that mean 2.21 units, and that'll be at the negative 2.21. And our goal in calculating the probability that a z-score, because we're in the standard normal distribution, is less than negative 2.21, is find that area under that curve, and we use our normal cumulative distribution table in order to get that. And so what we're going to do is we're going to go through that last example that we didn't get to. We want to find the probability that an observation is within 0.45 standard deviations of the mean. And so what we're going to do here is I'm going to draw my normal distribution, my bell-shaped curve. It's a little messy. And I want to be within 0.45 standard deviations of the mean. That means if I go to the right, 0.45 units, and if I go to the left, 0.45 units, that's going to give me a negative 0.45. I am going to end up with this area right here. So my goal is to find that probability. Now, since we're in our standard normal distribution, because our mean is 0 here, then our goal is to find, instead of saying x's, we say z, but the probability that z is between negative 0.45 and positive 0.45. Now, remember, when we do this, we rely on our standard normal distribution table, right? Remember that that table gives you the cumulative probability, the probability that z is less than or equal to some number. And so since that table is restricted to that, what we're going to have to do is we're going to have to do some manipulation here in order for us to do that. If I want to know just this in-between area, one of the things that I can do is I can find the entire area that's less than that positive 0.45, right? So what I'm going to do is I'm going to find a probability, all right? And let's make sure that you can actually see this. So I'm going to find the area less than or equal to this positive value here, or the upper limit of that region that I'm looking for. So that's the probability that z is less than 0.45. And then I'm going to subtract from that the probability that I'm less than this left endpoint of that area that we have there. So if I do the whole thing and I take away this part, I'm going to be left with just this stuff right here, which is what I need, right? And so I'm going to subtract off the probability that z is less than negative 0.45. All right. And so when I go to my normal distribution table, all right, well, since I'm on the positive side of that table, I'm going to go to 0.4 and then go over to the column that says 0.05. So that give me 0.05. I get 0.6736. 0.6736. And I'm going to subtract from that what I get when I get my z-score that's negative 0.45. And if I go to the negative side of my sheet, negative 0.4, 0, 1, 2, 3, 4, 5, that's 0.3264. That's 0.3264. And when I do that subtraction, I'm going to end up with 0.3472. So that's the probability that an observation is within 0.45 standard deviations of the mean. All right. So now what we're going to do is we're going to switch gears and we're going to kind of do some things a little backwards, right? So example 3 says, for a normal distribution, find the following. In part A, we're going to find the z-score. What z-score is at the 78th percentile, right? Remember that a percentile, right? If you're at the 78th percentile, that means 78% of observations fall at or below the z-score, all right? If I want to know the z-score, right? And so if I think about my normal distribution, I have 0. I don't know the z-score, right? So I'm just going to put a generic z-score, and I'm going to put a subscript 0 here because I'm going to find that value. That's what I'm trying to find. But what I do know is that that z-score should correspond to the area that's less than, under the curve, that's less than or equal to this z-score is a 0.78, right? Or that 78%. And so what we're going to have to do here is we're going to have to find the probability that z is less than 0, z sub 0 equals 0.78. So this time we know the probability, and our goal is to find the z-score. From before, we've known the z-scores, right? This is a z, this is a z. In a previous example, those were z's that we knew, and we found the probabilities, right? This is the probability, which is the area under the curve, right? And so what we're going to do here is we're going to have to kind of use our standard normal distribution table backwards. We're going to have to look within our table to find the number that's closest to 0.78 and find the z-score that corresponds to that. And I'll show you what I'm talking about. Now, all of the values that are on the front, on the negative side of this cumulative distribution sheet are values that are less than, since the z-scores are less than 0, they're on the negative side, right? That means they're going to be 50% or less. So I'm going to go to the positive side. And what I'm going to do here is I'm going to try to find the number that's as close to 0.78 as possible, right? So if I look, it starts at 0.5 and I start to get some 0.7s. I get some 0.79s here. If you look, oh, that's 0.7995, and then there's 0.8023. So between these two here, I'm getting very close to 78. Uh-oh, nope, that's not 78, that's 0.8. 0.78 is over here. I get 0.7794 here. I'm not sure if you can see, I'm gonna zoom in a little bit. 0.7794 here, and then 0.7823 here. The one that's closest to 0.78 is that 0.7794. So I'm going to use the z-score that corresponds to this. Well, it's on the row with the 0.7, and it's on the column with the 0.07. I put those together, that's 0.77. All right, that's 0.77. So what I'm going to do here is that z-score is approximately 0.77, right? So I get z naught equals 0.77. All right, that is the z-score that corresponds to the 78th percentile. What z-score is at the 20th percentile? I'm going to do something very similar, but this time, if I'm at the 20th percentile, that means that 20% of the observations fall at or below that z-score, right? Now, since it's 20 percentile, I know that this is the 50th percentile here, right? So 20th percentile has to be somewhere over here. So this is the z naught that I want to find, right? I want to find the z naught such that if I do the probability that z is less than z naught, I get as close as possible to 0.20. And it pictorially or graphically is going to look like that. We know that that's 0.20. Well, since this is a value that's less than 0.5, I know it's on the negative side of my cumulative distribution sheet. And so I'm going to scroll to the negative side, and I'm going to try to find 0.20 on my thing here, right? Okay, well, look, I'm at the bottom, and I get some 0.2s. If I look here at negative 0.8, this 0.2005 is closer to 0.2 compared to 0.1977, right? And this is 0.8, and if I scroll on to the top, negative 0.84 looks like it's my z-score. And so that's what I'm going to say. In this case, we have that z0 equals negative 0.84. All right, and then part C, what is the percentile for an observation with the z equal to negative 0.23? Well, negative 0.3. All right, so this time I'm given the z, right? So we're switching it up again. And if I could, okay. So I can't clearly draw a straight line. All right, so zeros here, negative, we're getting z equals negative 0.23. And I want to know the percentile, right? Well, if I want to know the percentile, I got to know the percent, right? So this is back to the normal way that we've been doing things. I need to find this probability here so I can change it to a percent, and that's going to be my percentile, right? So all I have to do is find negative 0.23 on the edges of my table, and that's going to help me get my answer here. So I'm going to go back to my cumulative distribution table. I'm going to scroll down to negative 0.2 and scroll on. That's 0, 1, 2, 3, and I get 0.4090, 0.4090. So this equals 0.4090, and in fact, that is the probability that z is less than negative 0.23. And that as a percentage is about 41%. And so my percentile is the 41st percentile. Remember, to change it to a percent, you move your decimal 2 places to the right. That's equivalent to multiplying by 100. And if I round it to the nearest whole number, I'll get to the 41st percentile. All right, so that does that one for that example there. Let's look at another example up. Let's go to part D, sorry. Find the z-score for which the total probability of 0.03 falls more than 2 standard deviations from the mean. All right, so the total probability of 0.3 falls more than 2 standard deviations of the mean. So basically, what this is asking us to find is the z-scores such that the total probability falls more than a certain number of standard deviations from the mean, 2 standard deviations from the mean. All right, that basically means if I take this side, I'm going to be more than 2 standard deviations from the mean, and I take this side and be more than 2 standard deviations from the mean. I want this plus this to equal 0.03. And so basically, I need to find the z0 here, the z-score, and it's going to be the opposite sign there, a negative z-score on that side that'll allow me to do that. So that this whole total, when I add those two together, is going to be 0.03. Well, if I divide 0.03 by 2, I'm going to get 0.015, right? So I know that this area here is going to be 0.015, and this area here is going to be 0.015. So all I really have to do is find the z-score that's negative that gives me that negative 0.015 within the table, all right? Within the table. And so I'm going to scroll back to my table. I'm going to look within my table, and I'm going to find the probability 0.015. Now I have 0.05, 0.04, 0.017, 0.03. All right, I'm going to scroll to the right. Oh no, I got to go down lower. Ooh, 0.0150 exactly is sitting here. And that corresponds to the z-score of negative 2.1. And then if I go to the hundredths place, 7. So that's negative 2.17. So I know that this z-score actually equals negative 2.17, and this one equals a positive 2.17. So I'm going to say Z naught equals 2.17. All right. Now to an example where we actually get to some real life examples where we work with our standard normal distribution. In this example, it says a WeFit study tested men and women ages between the ages of 20 and 24 years and found that the mean amount of calories burned after 30 minutes on the super hula hoop was 111 calories, right? Remember, when I know I'm dealing with a distribution, I know I'm going to need my mean, my parameters. The mean is 111. Suppose the distribution of calories burned is bell-shaped and the standard deviation is 20. That's another parameter for the normal distribution. It says a 22-year-old woman burns 130 calories on the super hula hoop. What is her z-score, and then what is her percentile? Well, the z-score for this woman would be x minus mu over sigma, right? Our x is her actual number of calories, which is 130. I subtract the mean from that, which is 111, and I divide it by the standard deviation, which is 20. When I do that, I get a z-score of 0.95, right? So this is her z-score. What is her percentile? Well, now that I know the z-score, the percentile is the percentage of the people who are observations that are at or below that value, right? So I know 0. Now that I have it as a z-score, I know I'm in standard deviation units. I can go to 0.95. And since a percentile is the proportion or percentage of individuals at or below that value, all I have to do is find the probability that z is less than, or you can use less than or equal to. Really, it doesn't matter, but it's the probability that z is less than 0.05. And basically, we can go to our normal distribution table. I'm not going to go there in this example. I think you guys get the hang of it. And if not, definitely try it out. But we get 0.8289. If I multiply that by 100, I move it 2 places to the right, and I'm going to round that to the nearest whole number for a percentile. That's going to be the 83rd percentile. All right. It says, how many calories would a man or woman have to burn in a super hula hoop in 30 minutes to be at the 85th percentile? All right. So this time they're telling us what the probability that we need to have, right? And so if zero's here, oh, okay. Well, I don't even know the z-score that corresponds to the 85th percentile, right? And so once I find that z-score, then I can convert it to an actual x by using this formula here because this has the z and the x in it, right? But what they're telling us is that this area right here is 0.85, right? And so if I go to my standard normal cumulative distribution table, what I'm going to do is I'm going to try to find the value that's as close as possible to 0.85. It is on the positive side. And if I do that, go to 0.85, notice here I get some 0.85s, 86s. Notice here 0.8485, and then I have 0.8508. It looks like I'm closest at this value here, 0.8508. That's a 1, 0, 1, 2, 0, 0, 1, 2, 3, 4. It looks like I'm at 1.04. Remember, you can go ahead and verify that there. And so our z-score here is 1.04. So a z of 1.04 corresponds to an 85th percentile, right? So the probability that z is less than 1.04 equals that 0.85, right? Well, what we want to do is we want to know how many calories, right? And so if our z-score is x minus mu over sigma, and we know that our z-score here is 1.04, and we want to know the calories here, that's our goal here, that's what we want to solve for. Well, we know the mean of that distribution is 111, that was given in the problem above. The standard deviation is 20. Let's solve this equation for x. First thing I'm going to do is multiply both sides by 20. So I'm going to get 20 times 1.04 equals x minus 111. And then I can add 111 to both sides. I'm going to get x equals 20 times 104 plus 111. And you put that in your good old calculator, and you will get approximately 131.8. And the units there are calories. All right. And so that's a way that we can go and use the 85th percentile to get the number of calories. We have to first get the z-score, and from that z-score, we can go back to our equation that allows us to relate our z-score to our observation with the mean and standard deviation. We can solve that equation for x. Our last example that we're going to look at in this video is this one here. It says the mean score on the SAT variable is 500 with a standard deviation of 100. The mean score on the ACT is 21 with a standard deviation of 4.1. The distribution of both scores is bell-shaped. John scored 550 on the SAT variable and Jack scored 22.5 on the ACT. Find John and Jack's percentile, right? Well, let's first start at John. All right. What I'm going to do is, because I want a percentile, I know I'm going to want to get probabilities. In order for me to calculate probabilities using my continuous normal bell-shaped distribution, I'm going to change everything to a z-score, right? So for John, his z is going to be x minus mu over sigma. His score was a 550, and he did the SAT, which had a mean of 500 and a standard deviation of 100, right? And so his z-score was a 0.5. All right, that is John. For Jake, he took Jack took the ACT, and again, we use the same formula for our z-score. His actual score was 22.5. The mean on the ACT was a 21, and the standard deviation was 4.1. When you get that calculated and rounded to 2 decimal places, because our cumulative distribution table only does 2 decimal places, we get 0.37, right? So if we want to know the percentile, we got to first find the probability that z is less than 0.50 for the first person, who is John. And then we have to find the probability that z is less than 0.37. When you use your cumulative distribution function, you're going to see that you get 0.6915 for John, and here you see you'll get 0.6443. You multiply these by 100 and round it to the nearest whole number. The percentile here will be 69th, and then the percentile here will be 64th. All right, and so who did better? John did better because he had the higher z-score and percentile. It's like saying the same thing. I'm repeating myself. If you have the highest z-score, you're going to have the highest percentile. But this does it for this video of using the normal distribution in order to help us either calculate probabilities or find z-scores. And that concludes the video.